Hey everyone, Chang here. This is the skill building video series. For today's topic, I'm going to go over how we graph basic linear equation. Now there's two ways that we can graph basic linear equations that is most commonly taught. The first one, which is the most tedious way possible, is that you actually start plotting in points, because guess what, line is just an infinite amount of point that I guess you could say follows in that basic pattern that creates what we know as a line. Now what do I mean by that? Well, here's a basic linear equation. One way is this t-table. What they do is they have a, well, what you guys can guess, a t-table. One of them is going to be an x and one of them is going to be a y. And what they do in this case is they start picking random numbers for either x or y and then solving for the other. So for example, if I wanted to graph using the t-table, I would just start picking random numbers. Let's just say, for example, I pick 0. So I would plug in 0 for x. This whole thing's become 0. So y equals -1. So then I would figure out that, okay, y equals -1. That's 1 point. And then I would keep going, right? I could put in, for example, 2. Well, let's write it right here, 2. 2 plug in here, the 2 cancels out. It's going to be 3 minus 1. That's going to be 2. And that's what our y is going to equal to. And I keep going on and on and on. And I start plotting all these points. So you have 0, -1. So 0, -1 is about right here. And then you have a 2, 2. So it's going to be 2 and 2 is going to be right here. And I start plotting a lot of the points. And it will eventually form basically what we know as a line. That's one way to go about it. And that's a good way to show why we use points and the t-table and what the linear equation actually means, right? It's just basically a relation of x and y such that this statement is true. Now, I'm going to go a different route. Today, I'm going to go basically over this format and how this format can actually help you graph it a lot easier than having to go through a t-table. So this format is called the slope-intercept. Slope-intercept. And this is the most common format you will see a linear equation. Basically, it's in the format y equals mx plus b. M is our slope. And I'm going to go into details what a slope is in a bit. And then y, or b, is our y-intercept. Okay, so that's what this format is. So if we look at this linear equation in comparison to this format, we can see our slope in this case is going to be right here, our 3/2, and our y-intercept is going to be right here, our -1. Okay, so this is our m and this is our b. Now, why is that important? Well, it's important because guess what? Without having to go through this t-table, let's just erase this t-table so it's not in the way anymore. And I'm going to erase this right here and just redraw it so that we can see exactly what I mean. So we have our coordinate plane, and I'm going to draw it really quickly. So if it's ugly, I apologize for that. All right, and then we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, anyways, we have our slope and our y-intercept. Now, what is a slope? The slope, by definition, let's just write it right here. Slope is equal to the change in y. This just means change, not triangle. Change, right? So how high one point from another, the change, how high the distance is, over the change of x. How wide from, well, the x-coordinate from this point to this point is. That's what slope is. That tells you basically this little, I guess you could say incline, the degree of this incline right here. That's slope. Now, that's very important because all line has a degree of incline, right? It could be flat, it could be completely straight, or it could be some angle in some way, shape, or form. That would give us a line. Now, the intercept is basically where the line crosses the axis. In this case, the y-axis, or y-intercept, is going to be where it crosses the y-axis. If it's an x-intercept, then it's going to be where it crosses the x-axis. So, with a basic equation like this, knowing that this is a slope, knowing that this is where it's going to cross the y-axis, we already can draw our line. So let's just look at this. Y-intercept, our y-axis, is going to be -1. So we know that whatever happens, the point's going to cross the y-axis, this axis right here, y, at -1. So it's going to be right here. That's where one of the point of the line is. Good and done, right? Now, we have our slope. our slope, once again, is the change in y over the change in x. So in other words, whatever happens, the top part is going to be the change in y, so it's going to be 3. It has to go up 3 or down 3. And the change in x is going to have to go right 2 or left 2. So from this case, right here at this point, we're just going to pick this as the point, and we're going to go up 3, right? 1, 2, 3 right here. And then we're going to go across 2. 1, 2. So right here is another point, just because we're following this basic path, this basic slope format, right? We know that no matter what, the point is always going to be in the ratio of 3 over 2. So in this case, just drawing a line, I don't have a ruler, but if you draw a line roughly like that, this line right here, all this point would make this particular statement true. So let's move on to the second example, and hopefully it will be a little more clear. All right, so here's the second example. I've included all the basically formulas, or whatever you want to call it. We have our slope-intercept form. We know that y equals mx plus b, slope, intercept. And slope itself is just the change in y over the change in x. Now, here's our basic equation. Once again, we know that it's going to be y equals mx plus b. But what happens in this situation where there's not a number in front of x? Well, in this case, we know that this is technically an invisible one. Okay, what's even better is that 1, if you write it as a fraction, is just 1 over 1. Okay, so our slope is just 1 over 1. That's wonderful. That means that whatever change in, every time you change 1 in y, you're going to change 1 in x. Simple as that. All right, so that's our slope, and then our intercept is right here, the minus 2. Okay, so in order to graph it, first and foremost, let's just pick where the intercept is. That's negative 2. So it's going to be at the y-axis 1, 2 right here. This is our first point. And we love it because guess what? The slope, once again, change in y over change in x, 1 over 1. So if I were to go up 1, I would go over 1. That would be a point. Now here's the thing. The reason I say up or down, left, or right is because up 1 over 1, that's fine. But if I go down 1 over 1, notice that it's still in the same pattern. Theoretically, if I keep on going, if I draw a line right here, all those points should still fall on this line. And this line is the representation of this equation right here. Now, for this third example, we have this one right here. Y equals negative 2x plus 1. Now, once again, our slope is right here in front of the x. This guy, that's our slope. And this right here, plus 1, is our intercept. Now, here's the thing. The intercept is easy. It's just 1, right? So our y-intercept at 1, this is where our first point, or where our chosen point should be. And then from then on, we're going to use the slope. Now, slope is a little different in this case because guess what? It's a negative slope. What does that mean? So that means that instead of going up and then over, this would mean I would have to go down and then over. So let's just write right here so you guys can see it. It's going to be down and over, right, I guess you could say to the right. Instead of the original, when it was positive, what we normally do is we would do up and then to the right. Okay, so this is not what we're doing now. This is what we're doing. Okay, in this case, negative 2. Negative 2, if you write it as a fraction, is just negative 2 over 1. Well, from here, we're going to go down to 1, 2, and then 1 over. So this would be our next point. And we wanted to continue, it would just be down 1, 2, and then 1 over. Right? Right here. And then we can keep on going. And so when we draw a line, it should theoretically go through all those points. This line right here would represent this linear equation. Now for this final problem, I'm going to refrain from giving an explanation. Now, this is a combination of all the ones you've gone through so far, so hopefully you guys can follow along. Thank you for watching this video on graphing basic linear equation. Basically graphing slope-intercept form. See you in the next one.